Scale and similar shapes. First, I want to review what we went over yesterday. The scale on a scale drawing is the ratio of drawing lengths to its corresponding actual lengths. So we're talking about a scale model, something small representing something large. So like a dollhouse representing a big house, or a scale car, model car representing a big, actual car that you can drive. So in our scale, 3 inches equals 1.5 feet. So your scale, again, is the ratio of the model length to the actual length, and it includes your units. Scale factor takes the scale ratio. We convert both of the numbers to the same units. So our scale had inches and feet. Scale factor, we convert everything to inches. And then we drop our units. So the scale is 3 inches to 1.5 feet. Our scale factor is 3 to 18, where both of them are inches. So for every 3 inches, we have of our model, it represents 18 inches of the actual. And then we will simplify this if it's able to be simplified, where this one is, and it simplifies down to 1 to 6. So the scale, it lists the units. The units can be different. Scale factor, there are no units. The units have to be the same. Both of them are ratios. Both list the model number first and the actual number second. Those are important things to remember. When you're dealing with drawings, traditionally it's the smaller one is first, the bigger one is second. We use scale and scale factor to enlarge objects and to reduce objects. So if we're looking at shapes, we can take a shape and we can enlarge it, or we can reduce it using our scale factors. And we can, as long as all the measurements are the same, and that's the key thing, your dimensions that are enlarged and reduced have to be the same ratio, or they have to be reduced and enlarged by the same amount in order for your shapes to be similar, in order for them to be an actual enlargement or reduction of the original object. Kind of like a copy machine where you take a piece of paper, a drawing, and you enlarge it or reduce it. It enlarges and reduces the drawing by the same amount. Does not distort the image, just makes it bigger or smaller. So we use ratios to make objects bigger and smaller, and these ratios are our scale factors. So if we have a scale factor of 2 to 5, we have equivalent triangles. This original one is 2 inches by 2 inches by 2 inches, and we enlarge it to a 5-inch by 5-inch by 5-inch equilateral triangle. Because all sides are the same, they're similar triangles, okay? So if the sides were different, then they would not be similar. But because it remains an equilateral triangle and all sides are still the same number, that's what equilateral triangles are, then these are similar and they have a scale factor of 2 to 5. We're going to keep the same scale factor. And now we're going to take a 4-inch triangle and we're going to enlarge it. Well, I know that 2 times 2 equals 4. So if I'm multiplying this by 2, I have to multiply 5 by 2. So m should be 10. Okay, so I know it's going to be 10. I'm going to show you how to figure that out using two different things. You can use an equivalent unit ratio, or you can use a proportion. Okay, there are other methods too, but these are two things that you already know how to do. So unit rate or equivalent unit proportion, you're going to take the 2 to 5 scale factor and you're going to write it as a fraction. When you write it as a fraction, I want to take my top number and I want to make that 1. Okay, so my smaller number, I want to make that 1. So I have to divide my denominator by 2. And 2 goes into 5 2.5 times. So my equivalent unit rate or my equivalent ratio, scale factor ratio is 1 to 2.5. So I use that to enlarge my small original triangle, and I multiply 4 inches by 2.5. Well, 4 times 2.5 is 10. So this proves that this triangle has a size has a side measurement of 10 inches. The other way we can do it is write a proportion. So I'm going to show you two different ways of solving with the proportion. So you set it up, your scale factors on one side as a fraction, and then your two triangles are on the other side. The 2 represents my smaller triangle. So I put my 4 on the same level. They're both in the top number. My 5 represents the bigger triangle. That's on the same level as my variable. So they're both bottom numbers. So I look at it. How do I go from 2 to 4? Well, I multiply it by 2. So if I multiply the top by 2, I have to multiply the bottom by 2. So 5 times 2 is 10. So again, the variable m is equal to 10. I can also solve a proportion by cross multiplying. 2 times m, 4 times 5. Well, 2m equals 20. So now I have to solve for my variable. I divide both sides by 2. M again is 10. So there's different ways to solve for your variable. Use the way that works best for you, okay? If I'm going to go the other way, if I'm looking to reduce my triangle, my big triangle, make it smaller, okay? I'm looking for the smaller number. I'm looking for the first number that corresponds to my scale factor because this 15 corresponds to the 5. I want to figure out what the C is, and C corresponds to 2. Well, I know that 5 times 3 is 15. So I have to multiply 2 times 3. So C should be 6. So you can find unit rate again, or you can use a proportion. So I'm going to quickly show you how to use a proportion to solve. So again, I know to go from 5 to 15, I have to multiply by 3. Okay, so I'm going to multiply my numerator by 3. 2 times 3 is 6, so this is 6. I could have also cross multiplied. 2 times 15 is 30. 30 equals 5c. I divide 30 by 5. Well, 30 divided by 5 is 6. So there's a bunch of different ways that you can go about doing this to solve. So now we've done an enlargement, we've done a reduction. So I want you to take some time and to practice enlarging and reducing shapes using the Google document that is attached to this assignment, okay? If you have any questions, find me in Google Hangout or post a message asking your question, and I will get to you as soon as I can. But I'm in Google Hangout almost every day from 9 o'clock to 12 o'clock. So come during that time and ask any questions you have. Do your work on the file and turn it in. And I'll look through it and I'll let you know what problems you have, and I'll help you through any questions you have.